AP Chem students, and welcome to topic 3.8, representation of solutions. The learning objective here is 3.8.a, using particulate models for mixtures. And there's two parts to this. One, represent interactions between components, and two, represent concentrations of components. So let's look at what this looks like. So when we represent solutions, we do this because, as with many concepts in chemistry, it can be easiest to visualize this very, very small nanoscale, microscale situation by drawing a diagram of the mixtures to show their features. In solutions, we generally draw diagrams to help illustrate two features, and these were both listed in the learning objective. Number one, interactions between the components, and number two, relative concentration of the components. So the easiest way to do this, like to teach you this, is just to show you an example. Now, we looked at a couple of examples already in the last video. So we saw this one where you can see the number of dots increasing as concentration increases. And then the same thing down here. You see a solute particle represented in blue and solvent in purple. And then in concentrated, we have more blue relative to purple. And then in the dilute, we have less blue relative to purple, so a greater amount of purple. So this is two ways you can do this. Now, what we've been seeing more often on the AP exam would be this kind of situation up at the top where you're just representing the solute particles, because the solvent particles can be too overwhelming. Now, a lot of times in the multiple choice, you might see ones that look more like this, where you would have to distinguish between the solute and solvent and make kind of a quantitative decision there. But let's just look at both situations and ways in which we've seen AP ask you to sketch this on the free response section. So, for example, the following diagram illustrates, there's the diagram, a 0.2 molar solution of NaCl. Sketch the representation of the same volume of a 0.4 molar sample. So if they provided this as the 0.2 molar sample, then to go to 0.4 molar, then obviously that is a concentration that is doubled. So in this top, or in this original diagram, we've got 4 Na plus and 4 Cl minus. And so if we're going to double that, we need to have double the amount of dots. So we would need 8 Na plus and 8 Cl minus. And so you can see that that's what we've done here. Got 8 dark blue and 8 light blue. You do want to make sure that you're paying attention to the subscripts or ratios of your amounts. So in this case, it's pretty straightforward because it's 1 to 1. But in a situation like if we traded out the Na for something with a +2 charge, like Ba, and you had BaCl2, you would need to make sure that you had twice as many chlorides as you did bariums. So do make sure that you're paying attention to the ratio of the ions, particularly when you're looking at something like this that's an ionic compound that will dissociate. So the second scenario that they presented in the learning objective was showing interactions between the particles. So if you draw a diagram showing how waters arrange themselves around the sodium ions and the chloride ions in a salt solution, and draw water this way, the first thing I want to say is if they tell you how to draw something, please draw it that way. As an AP reader, it makes it much easier to award students points correctly if they have followed the directions exactly. So in this situation, you might be given a box with a circle and that's labeled as Na. And so they would not ask you both of these on the same exam, but I wanted to show you both situations so that you can compare them and see the differences. So the big thing here is that we know that water has an area of partial negative on the larger atom, which is oxygen, and has an area of partial positive on the smaller atoms, which are hydrogen. And so in this case, because sodium is positive, we need to orient the water so that the partial negative end of the molecule is closer to the positive ion. And so you would see it look like this. Now, we have been seeing them specify the number of waters that you need to draw in the sketch. So this would be if they had told you to draw 3. Again, please draw the number of particles that they ask you to draw. A lot of times in the scoring guide, it says something like, they might give you something in the prompt that tells you the number that you have to draw, and then they set some kind of threshold where they say at least 3 of these particles must be oriented correctly. If you haven't drawn at least 3 particles, there's no way you can earn that point, even if you drew the 2 particles correctly. So just pay close attention to directions and make sure that you're doing what you're asked. Now, in the situation with chloride, obviously we would orient these waters in the other direction. because the positive, partial positive end of the molecule needs to be oriented towards the negative ion. So in this situation, you want to make sure that you pay attention to the orientation of dipoles relative to charges or relative to other dipoles. It would not surprise me to be asked to sketch like water and the hydrogen bonds. Now, we often see sketches of the hydrogen bonds in the multiple choice. So that is a pretty common thing to ask you to maybe not produce yourself, but to evaluate a sketch of. So that's it. So what should you be able to do with this? You should be able to draw a representation of a solution that shows the correct proportions to represent concentration. And you should be able to draw a diagram that shows the interactions between the solute and solvent, especially regarding orientation. And so then you can use that to be able to explain the intermolecular forces between them. That is it. And I'll see you for the next video coming up soon.